Hello, everyone. We are Design Team 28. I am Jennifer Hauser, and presenting with me is Stephen Dooley, Ibrahim Eltahir, and Christine Hilbert. We are working with Moog in Christiansburg, Virginia on occupational ergonomic assessments and solutions with our client contact, Sean Wildman, and our faculty advisor, Dr. Dickerson. Moog Incorporated is an organization that designs and manufactures products for a variety of industries. The Christiansburg location manufactures commercial and industrial slip rings for use in imaging devices, for example. In 2020, they shifted these departments for 2 locations in Blacksburg to a new facility in Christiansburg and hired a new environmental health and safety manager, spurring the idea for this opportunity. Moog asked us to look at their legacy processes and analyze the ergonomics of the 2 departments, which employ about 25 individuals. The commercial rings range from 1 to 6 inches in diameter and require small hand and wrist movements, while industrial rings range from 40 to 60 inches in diameter and weigh about 50 pounds. These require large-scale movements and team lifts. Next, Stephen will discuss our opportunity in depth.
Thank you, Jen. Our project is unique in that Moog gave our team the opportunity to find areas in their manufacturing department that could have ergonomic risks reduced. The field of ergonomics focuses on reducing long-term physical injuries and improving performance of physical tasks. Our team has been taught the key principles of ergonomics while here in the ISC at Virginia Tech. So Moog asked us to explore the manufacturing department and evaluate the risk of certain movements. An example is shown here in the commercial slip ring area, where a worker is reaching above their head to lay lead wires onto a holder. These evaluations gave our team the opportunity to design solutions to reduce these risks. We designed several solutions and narrowed it down to 3 different ones that we'll show you a little bit later. Following the previous example picture, our interviews with workers showed that lead wires could fall and create a trip hazard, and even sometimes the holders would hit their heads sometimes. So we tried to design a solution to mitigate those risks. Finally, we got the opportunity this semester to implement our solutions and reevaluate the risks to ensure that the ergonomics of the tasks had been improved. Here's an example of the improved lead wire holder that's lower, softer, and bent. I'm now going to talk about the objectives for this project. Moog helped us come up with 3 main objectives for our solutions. The first was to reduce the risk by 25%. We measured this decrease using standard ergonomic tools of quantifying risk, which Christine will talk about in a little bit. The second was to improve the comfortability of the manufacturing operators. Many of these workers had been there for 20 to 30 plus years and know their tasks inside out. So we didn't want to change their flow in an unnatural way. Even if we believe that it's a better ergonomic improvement, if they don't like it, we don't want to do it. We quantified this objective through operator surveys throughout this entire past year. Our third and final objective was to increase the efficiency of these tasks by at least 10%. This is more focusing on the improved performance component of ergonomics, and we quantified this through a time study. Christine is now going to give y'all a brief overview of the impact of our project.
Thanks, Stephen. I will now be talking about our impact summary. We found on quantifying the impact of our project that we contributed to 2 main areas of savings: labor cost savings and injury cost savings. First, labor cost savings. Through implementing our solution, we found that we were able to decrease the task labor hours by 90 over the course of a year, or 270 over the course of 3 years, which would equate to $27,040. Next, our injury cost savings. With the implementation of our solution, we found that we will be able to reduce the number of injuries by 2 per year. We then used the OSHA Safety Platform Injury Estimator to determine the cost savings per year and then over 3 years. So over 3 years, the cost savings would be $376,020. This would mean a total of $403,060 in savings for the company over 3 years. Moving on to our solution approach, we used 4 industry standard assessments. The first was the RULA, which is the Rapid Upper Limb Assessment. This focuses on the posture of the arms. We used this to evaluate 7 of the areas we looked at. Next was the REBA, which is the Rapid Entire Body Assessment, which focuses on the posture of the body as a whole. We used this to look at 2 of our pictures. Next was the Strain Index, which focuses on strain in the wrist, or those small movements that operators have to do. We used this to evaluate 2 of our pictures. Finally, we used the NIOSH lifting equation, which focuses on the risk associated with lifting loads, and we use this to evaluate 3 of our pictures. We then took our RULA and REBA and we put our solutions in different graphs based on the solutions and their scores. So on the left side of the screen, you can see all of our RULA scores. The ones highlighted in red are the ones that are the ones we chose to proceed with. You can see on the RULA that there was one higher than the one we chose, which is the automatic torquing wrench. We spoke with our client, and as a group, we decided to not proceed with this one at this time. We decided to go with the lead wire holder, and the automatic torquing wrench could be a potential solution in the future. For the REBA, you can see that the chest level containers, which is the solution we chose to proceed with, was the highest one, and therefore that is what we did go with. I will now pass it over to Ibrahim.
Thank you, Christine. Here we have an example rapid upper limb assessment. On the left, we have an operator using the lead wire holder in the commercial department. And on the right, we have a RULA assessment worksheet. When performing a RULA assessment, we give scores to the different joint angles of that posture. And things that raise a RULA score are extreme or awkward postures. There are also supplementary or added scores, and these apply when limbs are raised, bent, twisted, or tasks are prolonged, repetitive, or weighted. So if we go ahead and look at step 1, and we see that the upper arm position is well past 90 degrees, and that gives us a +4. And if we look at step 1A, there is an adjustment factor because the shoulder is raised, and that gives us a +1 for a total upper arm score of 5. So if we were to continue the RULA assessment for steps 1 through 8, we'd end up with the wrist and arm score of 7. And if we continued with steps 9 through 15, we'd end up with the neck, trunk, and leg score of 3. So once we have these 2 final scores, we're able to go into table C and get our RULA score. So based off the wrist and arm score, neck, trunk, and leg score, we get a RULA score of 6, which means further investigation is needed and change should happen soon. These risk assessment scores are a rough initial estimate of risk, and the scores may vary based on who's assessing, just because things are so intricate and people may have different perspectives on the posture. And like I said earlier, this is a general identifier of problem areas. And just because the number is high doesn't necessarily mean that we'll automatically craft solutions. We definitely check with the operators and check to see if that was in their scope and our scope, and if that was something that they wanted to be tackled. So as we were identifying problem areas with the risk assessments, we designed many solutions to combat those problem areas. And after we did design those solutions, we conducted a failure modes and effects analysis on our solutions. What a failure modes and effects analysis is, it's a reliability and safety tool which points out areas of risks in systems and allows us to prioritize the actions needed to reduce the risk. So this is a supplemental risk analysis, and we did it alongside our previous risk analysis or risk assessments. And ultimately what you get with an FMEA is a risk priority number. This number is based on the potential failure and failure rates, consequences, detection, and occurrence of those failures. So basically, the higher the RPM, the more risk is associated with that process. And we conducted an FMEA on our solutions to determine which of our proposed solutions had the greatest risk associated with them and to find the faults in our solutions to be able to continually improve them. So by the time we give our client a solution, it's to the best of its possibility. So if you look at the ergonomic brakes has an RPM of 54, the main contributors here were that the workers may not want to accept the ergonomic brakes or take time out of their day to stretch. The chest level containers had a score of 60. The contributors here were that the containers could potentially interfere with the ring testing or that the measurements might be incorrect. And with the lead wire holder, we have a score of 54. This was because the wires still may slip or fall due to a faulty design and that there could still be a risk of injury. The extendable table, the automatic torque wrench, and the adjustable workbench all had low risk priority numbers, which theoretically means that we should pursue these solutions. However, they didn't match our client's criteria. What our client's criteria is that they wanted our solutions to be effective because we want our solutions to work. We want them to be low cost because Moog had just purchased a new facility and is looking to save money at this time, and easy to implement because if the solutions are not accepted by the operators, then there is no hope in them being implemented. So the solutions we did decide to go on with were the new lead wire holder in the commercial department, the ergonomic brakes in both the commercial and industrial department, and the chest level containers in the industrial department. Now I'll be passing it off to Jennifer to go deeper into our solution implementation.
The lead wire holder was an unsafe and ineffective method of holding wires in the commercial department. Metal rods at about 5 feet off the ground projected into the workspace to hold wires that protruded from the large through-bore slip rings. Our survey of the workers in this department told us that many workers have hit their heads on the old rods and the lead wires fell off frequently. We evaluated the upper body risk score at a 6 for this posture shown because workers often have to attach leads with their arms above 90 degrees for extended periods of time. However, the immediate safety goal was to reduce the risk of hitting their head. We prototyped this solution where we added a 2-inch bent arm at the top to catch leads from falling off, added rounded foam surfaces to protect the workers if they were to bump into it, and lowered the attachment about 2 inches below eye level. Moog implemented this solution over winter break following a safety incident, and they chose an out-of-box solution that does not protrude as far into the workspace, is about 4 inches lower than the previous, which led to a significant decrease in the upper body risk evaluation, and it features an angled end to hold the wires more effectively. Our next solution focuses on the ring testing device in the industrial slip ring department. With the chest level containers, workers on the industrial slip ring line were constantly bending over to grab screws, screwdrivers, and other materials to attach the rings to the testing device. These rings weigh about 50 pounds, and while the ring is being attached, the workers usually stabilize it with one arm. The walls of the testing machine are very stable, even though the machine spins at about 100 RPMs, which made securing the boxes you see in the lower right corner very reasonable. We evaluated the entire body score at a 10 due to the force of holding the ring, the range required, and the number of times operators bent over, about 8 times per ring each time a ring is tested. This led to an unexpected improvement where a heavy block used in the testing process will now be moved from above the operators' heads to where the old boxes were, thus eliminating an overhead risk hazard. The new risk score is a 4, since it is highly repetitive, but now the boxes are in the working range for the operators. Due to the reduction in the number of times that operators bend over to pick up materials, there is a productivity improvement, and the time it takes to attach each ring was reduced by 48 seconds, according to the time study. Next, Stephen will discuss our final solution.
Thank you, Jen. Our third and final solution was focusing on implementing ergonomic brakes for the operators to do stretches during them. When we spoke with operators, it was a common sentiment that many would have different kinds of joint pains depending on their tasks. Here are some direct quotes that we got from some of the workers, like, "I have back and shoulder pain when I get home. I would be willing to stretch for a couple of minutes a day in order to mitigate that pain. Many of them assumed that the pain just came along with the job and had accepted it. So we wanted to find a short time in their day where they could do specific stretches to mitigate that pain. We had a meeting with a physical therapist that was affiliated with Moog, that was in Blacksburg, and discussed the common injuries and pains that she found with these workers and obtained 6 different stretches that they could do depending on their pain. Here's an example of a stretch that they could do if they had neck or upper back pain. Here you can see that there's clear guides to the setup and the movement that you should be doing with clear pictures. We asked workers whether they wanted a designated time to stretch or just to do it on their own time, and every single worker said that they would prefer to do it on a need basis since they know when they have the free time. I'm now going to talk about the results of all of our solutions. Here are our results compared to the objectives that I discussed earlier in the presentation. We surpassed our first objective of reducing the risk scores by 25% with our solutions that decreased them by 33 to 60%. Christine will talk about the specifics of this in a moment. All of our solutions improved the comfortability of the workers, meaning we succeeded with our second objective. We conducted a final survey with the operators, and they unanimously stated that our solutions decreased pain and frustration with their implementation. This was kind of a given as we had worked with the operators throughout the entire semester or semesters, but just to make sure that it was actually surpassing the objective. Our last objective of increasing the efficiency of operators by 10% was also surpassed with an increase of 16%. The time study was done on putting an industrial slip ring onto the testing machine with our chest level containers to determine this increase. This task is completed about 100 times a week. So the workers stated this will be a huge improvement for them in terms of their efficiency, able to do other things during their time. I'm now going to hand it off to Christine to talk about the specifics of our risk reductions results.
Thank you, Stephen. I will now continue with our results, starting with our lead wire holder. It had an original rule of score of a 6. After implementation, it has a new rule of score of a 4. This means a risk of 33% from the original process. The next solution we had was our chest level containers. It had an original REBA score of a 10, and it has a new REBA score of a 4. That means that it decreased by 60% in risk. An expected but additional benefit is the productivity increase that came from implementing the solution. I will now pass it on to Ibrahim to discuss our summary.
Thank you, Christine. Throughout this process, we followed the ergonomic process. We had the opportunity to identify and quantify potential ergonomic risks. We did this by walking through the new Moog facility with the environmental health and safety manager, photographing high-risk postures and evaluating those postures using risk assessments. We were able to create objectives with our client and design solutions as a team. We had 8 potential solutions targeting problem areas identified by our risk assessments, conducted an FMEA on our solutions to identify issues in our solutions and improve them. And using our criteria, we were able to select solutions. We were able to implement the solutions and evaluate the effectiveness. Our original objective was to reduce risk by 25%. So in the industrial department, our goal was to go from a 10 to a 7.5, and we went from a 10 to a 4. In the commercial department, our goal was to go from a 6 to a 4.5, and we were able to go from a 6 to a 4 for an average improvement of 47%. We were able to increase efficiency by 16%, and we were definitely able to improve work comfortability. In terms of impact, we had a labor cost savings of $27,040. We had an injury cost savings of $376,020 for a total savings of $403,060. We'd like to say thank you to our client, Sean Wildman. Thank you to our advisor, Dr. Deborah Dickerson. And thank you to Dr. Chewbacca, the teaching team, and the IC class of 2022. Thank you. Do you have any questions?